Alright guys, good morning. So today we're going to start talking about the normal distribution stuff, the normal curve that we were looking at last week. As always this week on Monday and Wednesday you're going to have new videos to watch with notes, and then Tuesday and Thursday you have a worksheet that you're going to do on your own, and then Friday is your second test for the quarter. Okay, so a normal distribution curve, we kind of talked about this last week, but it's also heard a normal curve or a bell curve, probably you've heard it, is data with a symmetrical shape. So if you remember last week, I had told you guys that what we're going to be doing this week is really going to involve the normal curve, the one that's symmetrical. Now, if you remember this too, when your data is symmetrical, that means that the mean is equal to the median is equal to the mode. The mean, median, and mode is always the same thing, and it's always in like the middle point, the high point of it. Okay, so that's the first thing that you should know. Next, so this is what we're going to really be talking about today. The normal curve measures the number of standard deviations, away from the mean. Okay, again, the mean is in the middle. Measures the number of standard deviations away from the mean. So then using that shows the percentage, of a data set that lies a certain amount from the mean. Okay, it sounds really confusing in the definitions, but once you see like an actual example, it'll make a lot more sense. And then the last thing, that fourth bullet, it's used to calculate probability and percentiles. It's used to calculate probability and percentiles. So a lot of you have taken SATs already, or maybe you just took the PSAT. Anyway, when you take your SAT or PSAT and you go to your guidance counselor and they give you like how they give you your results, how you did, they'll tell you, oh, you're in the 50th percentile. If you're in the 50th percent, not you specifically, but if you are in the 50th percentile, that means that you are right smack on the mean. Okay, if you are in the 90th percentile, that's good. That means that you are above the mean. You did better than the mean. Okay, so important to note too before we get started, on the bottom of your bell curve, if you're going to do these notes on the computer, you have to be very careful because there's a lot of stuff all over the place. So I really suggest that you either print this out or you do it on notes in your on loose leaf. Okay, this symbol here, that means the mean. You might also see it as X bar. You saw it as X bar the other day, so you're probably going to want to see it as X bar being the little bar on top. And then this symbol here, this like sideways looking B thing, that's standard deviation. Okay? So what's important to note is that what this curve does is it shows where you are on a normal curve. So if you're one standard deviation away, if you're positive one standard deviation away, then you're here. If you're positive 2 away, then you're here. If you're negative 2 away, then you're back here, okay? So with this, there are percentages that go in between each section of where you are on this bell curve, okay? But you also are going by halves. So in between these lines on your paper, you're going to draw dashed lines. Your dashed lines represent half of a standard deviation. Okay. So this would be positive 0.5 standard deviations. This would be positive 1.5 standard deviations, 2.5 standard deviations, and then 3. You're not going to go more than 3. It goes too far out. This is minus 0.5 standard deviations, minus 1.5, minus 2.5. Okay, so if you are between the mean, which is right here, if you are between the mean and positive 1.5 standard deviations, you are with another 19.1% of the population. Okay, same thing if you are between the mean and minus 0.1. 19.1. I'm sorry, if you are between the mean and minus 0.5, then you are 19.1% with the standard, with the population. So if you are between minus 1/2 standard deviations and positive 1/2 standard deviations, you are with 38.2% of the population. Okay? As you keep going out, that number, that percentage gets smaller and smaller and smaller because you are moving farther and farther and farther away from the mean. So the next slot after 19.1 is 15.0%. It's symmetrical. It goes on both sides. That's 15.0. After 15.0, you have 9.2. And again, that 9.2 goes on both sides. After 9.2 is 4.4%, 4.4%. After 4.4% is 1.7%. Again, the farther away from the mean you are, the smaller the percentage is. Then you have 0.5. And then after your 0.5, you could still have some stuff on the tail ends here. So you have less than 0.1% of people. Less than 0.1% of people, okay? Now, the other thing with this is that there's something called the empirical rule. So the empirical rule says that if you are between 1 standard deviation away from the mean, you are at 68%. You are with 68% of the population. If the data is normally distributed, meaning it's nice and symmetrical like this, and you are within 1 standard deviation going both ways, you are with 68% of the population. If you are within 2 standard deviations, this is 95%. 95%. And if you are within 3, that is 99.7%. Okay? The way that you're getting these numbers, guys, if you add, for example, this 1 minus 1 standard deviation to plus 1 standard deviation, if you add 15, 19.1, 19.1, and 15, you end up getting 68.2, but these numbers are all rounded. It actually is 68%. Okay? So 68% for 1 standard deviation, 95% for 2 standard deviations, and then 99.7% for 3 standard deviations. And that 0.3% goes for the ends of those curves. Okay? So really this doesn't make any sense until you put it into an actual, if you apply it to an actual question. So let's look at our example down here. The test scores on a given history exam are normally distributed, meaning it follows the curve, and it contains a mean score of 75. So this is what we're going to do. We're going to say that the mean is 75. The standard deviation is 4. So 1 standard deviation is 4. Now remember, on our curve, we're going by halves. So I'm also going to say that half of a standard deviation, if 1 standard deviation is 4, half of a standard deviation is 2. Okay? So on our curve, we are going to draw 1 standard deviation out, 2, 3 standard deviations out, and then we're also going to put the halves in there. Okay? So, on the top of this, what I want you to write, this is how I want you to do it, guys. It honestly organizes it the best. This is the mean. This is positive 0.5. This is minus 0.5. Standard deviations. This is positive 1, negative 1. Positive 1.5, negative 1.5. Positive 2, negative 2. Positive 2.5, negative 2.5. And then 3 and negative 3. And then I want you to put the percentages in. This is going to be the same every single time, and then the numbers on the bottom are just going to change based on the question. So from our mean, the first one out is 19.1%. So we're going to write 19.1% in this little box. 19.1, 19.1. After 19.1 is 15. 15. Then 9.2. 9.2, and then 4.4. It's the same exact percentages every single time. Then 1.7, 1.7, 0.5, 0.5, less than 0.1, and less than 0.1. Okay? Now, what's going to change from question to question is what everything represents, like where is everything. So again, our mean was 75. So the mean you're going to put on the bottom is 75. And then you're going to add all the half standard deviations in. So a half standard deviation is 2. So if you're positive a half, you are at a score of 77. If you are at positive 1 standard deviations away, you are at 79. It was your score. You are positive 1.5 standard deviations away from the mean, 81. 2 would be 83, 85, 87. Okay? And then you do the same thing going backwards. So 75 minus 2 is a score of 73. Negative 1 standard deviations away would be a score of 71, which is 4 away. That's the 1 standard deviation. And you have a score of 69, 67, 65, 63. Okay? So, first question after the normal curve is drawn. And that's everything. That's it. Okay? So, letter B, what is the range of scores within 1 standard deviation from the mean? The range of scores, so that would be from 1 standard deviation away. So, minus 1 standard deviation, that's here to here. So if you are within 1 standard deviation away, you are between a 71 and a 79. Letter C, what percentage of students scored anywhere between a 69 and a 79? So if I look for that, I'll do this one with a green highlighter. A score of a 69, that's right here, and a score of a 79 is over here. So to figure out the percentage of students that scored between those, I would add all of the percentages up in the middle. So I would add all of these numbers together. So to figure that out, I would take all of the percentages, so 9.2, 9.2, there we go, 9.2 plus 15 plus 19.1 plus 19.1, and I stop at the next 15. I don't go to 9.2 because that's past the 79, the score of 79. So if I add all of those numbers together, that percentage would be 77.4%. Okay, so 77.4% of students scored between a 69 and a 79. And then the last question, if 175 students took the exam, how many of them scored within 2 standard deviations from the mean? So if you wanted to, you could take, I'll do this with the red highlighter, you could take 2 standard deviations right here, and and add all of these percentages, or you can just know that 2 standard deviations, we already talked about up here with the empirical rule, right? 2 standard deviations, that represents 95% of the data. Okay, so the question though is not what percentage of students scored, it's how many of them. So it's 95% of the 175 students. So to figure that out, you would do 0.95 times 175. And 0.95 times 175 rounded to the nearest whole gives me 166 students. Okay? All right, so again, your homework tomorrow will be a worksheet on its own. The examples are just like this last one. You're going to set up a normal curve, and then you're going to answer a few questions based on that. Okay? Later in the week, we're going to talk about what happens. For example, if you look here, what happens if your score is a 76 and now you're in between 2 of the half standard deviations. Okay, so that's what we'll do on Wednesday. All right, have a good day, guys.